Here is flight control, rocket is prepared for launch. Everything nominal, go for launch. 5, 4, 3, 2, 1, ignition.
Hi everyone, I hope you're doing fine. I'm Milad from Cyrux Space, and what you have just seen was the first and a second launch attempt or flight of my model rocket. And obviously it didn't go actually quite as planned, so we have a couple of things to discuss, so let's dive into it. The rocket I use is a 1/150th scale model of the legendary Chinese Long March rocket, which actually took the first Chinese people into Earth orbit.
07时30分31秒409毫秒 T0 伦敦正常。
I didn't build that model rocket, I purchased it from a manufacturer, and this is how it actually looks like. See, we have here the Long March model rocket in a 1/150th scale. We have a nose cone, we have the rocket body, we have 4 boosters, and of course 4 nozzles. Then we have a little spacecraft down here. That's the Shenzhou spacecraft, which actually took the first Chinese people into Earth orbit. You can take those solar panels off and you can put that spacecraft inside the nose cone. I didn't do that, but you have the possibility to do so. I didn't build that model rocket, but I assembled it. So let's have a quick view on how that looks like.
So first of all, we are going to unpack that package. Please keep in mind that I'm going to keep it short in this video because there will be a separate video in which I'm going to show you how I assembled that model rocket in detail. So this is the tube, which is the rocket body, and I think that actually looks quite cool. Then we have the nose cone. These are the 4 boosters of the rocket. And then we have some of the parts of the boosters, like the nose cone and the fins. These are parts of the parachute or parachute system, like the cords and stuff. And this is the parachute. Nice thing. First we are going to assemble the motor mount. And the motor mount goes inside the end of the rocket. Then we have to build the boosters. What you see here is the nozzle of the booster. Then we put on some glue. And then the nozzle gets its fin. And we do all of that 4 times. And here they are, 4 beautiful boosters. Now I have to do some measurements and put on some marks on the rocket. And here we have a piece which consists of 5 rings or lugs, which holds the boosters and the rocket together. And this is how it looks like after we glued all the boosters to the lugs. And then everything goes onto the rocket. So this is a little bit tricky, it takes a little bit of time to adjust everything. Okay, so now the boosters are assembled and we can proceed with the rest of the rocket. The next thing I did was to cut out the parachute. Here we go, that was easy. And then we have to tape each end of those cords on the marked positions on the parachute. And here we go. And then we pass the cords through the base of the nose cone. And then we pass the parachute through the middle of the cords in order to get it permanently attached to the base of the nose cone. And then we have a shock cord or rubber band, which one end is also tied to the base of the nose cone, and the other end is glued to the inside of the rocket body. After that, the parachute is folded and it also goes inside the rocket, and then you put the nose cone on.
So this is the Shenzhou spacecraft, which comes with that model rocket, and you have 4 wings or panels here with solar panels. See, but you can take those panels off and you can put that Shenzhou spacecraft into the nozzle if you want. I didn't do that, but you can do it if you want to.
But let's get back to the first flight and discuss what happened.
As you have seen in the first flight, the rocket didn't fly straight into the sky, but had more like a parabola flight trajectory or projectile motion, and this was due to the wind. There was a mild wind, but it still affected the flight trajectory. So this tells us that the impact the wind has on a flight trajectory is obviously not negligible. And you saw that clearly in the video. Besides that, the parachute did not open as it should. As you can see in the footage, the cords which were on the one side attached to the parachute and on the other side were attached to the rocket were twisted together or wrapped around, so that unfortunately prevented the parachute to deploy completely or open correctly. And what do we expect? A rocket in a descent which parachute did not deploy completely or correctly will sadly crash. And this is exactly what happened. But of course I did something about it, because you have to try to learn from your mistakes. So I did some research and looked a couple of videos on how other people are folding their parachutes of their model rockets, and I adapted that and tried a second time. I was really optimistic about the second flight and I was really looking forward to it, but as you have seen, it ended up in a crash too. And the reason was this little guy here. I mean, what can I say? It's always the little things that have the biggest impact. So what is this, you may ask? Well, this is a 3D printed object, and I call it protection out of a lack of a better word. If you have a better description or word for it, leave a comment below and we can give that a name. So what does it do? Well, we have here the launch pad. This is the launch pad. The rocket will sit on the launch pad. And we have this metal rod which goes inside the launch pad. See? This is the launch pad, this is the metal rod. And if you place the rocket on the launch pad and you have something to do before the launch, this actually made me a little bit nervous, because I don't know, you can poke your eye and it's a little bit dangerous. Not so, but I thought let's do something about it. So what I did was I 3D printed this protection. As I said, I'd call it protection because out of a lack of a better word. So I printed this protection, and this protection here goes on top of that metal rod. So what happened was that I just forgot to remove the protection. So the reason the second flight ended up in a crash was just my fault, because I didn't remove the protection on top of that metal rod. The rocket was ready. I think the parachute was folded correctly and it was in the better way. And it was just my fault. I didn't remove the protection and the rocket hit the protection, and that's what you see, the rocket crashed. But I have to say something about it. While I was 3D modeling that little guy here, I thought to myself, well, there is a potential that I might forget to remove that protection on top of that metal rod. And this is exactly what happened. So what I did was that I purchased this here. You know that everyone that comes out of the space industry is familiar with that, remove before flight. So I purchased it, but unfortunately the delivery was late, so I didn't have one. And as I said, you always have to try to learn from your mistakes. At least you have to try. So this is how it looks like now. And then you have here your metal rod, and it goes on top of that metal rod. I hope I am not going to forget it in the future. Let's have a look at the rocket motors I used. I used two different types of motors. They look like this. This is actually not quite spectacular. And I used two different kinds of rocket motors. Well, the first rocket motor I used was the A64 and the other was the B44. The A64 has a total impulse of 2.5 Newton seconds, a thrust of 6 newtons and a burning period of 0.6 seconds. The B44 has a total impulse of 5 Newton seconds, a thrust of 4 newtons and a burning period of 1.2 seconds. As I said, this is how the model rocket motor looks like, And how do I ignite them? Well, there is this electrical igniter. You pull that back and this goes inside the rocket motor and then you ignite it. So you pull that off and then you connect those two cables to the launch controller. This is the launch controller I use. I can show you that too. This is the launch controller I'm currently using. It's actually quite cool. You have two clamps here. Do you call that clamps? I think you call that clamps. See, you have these two clamps here and those, well, that's a little messy here. Wait a second. So you have those two clamps here, and where's the electrical igniter? You have this igniter here. As I said, this end here goes inside the rocket motor and you pull that off here, this here, and then there are two cables and those cables are connected to those clamps. Then you take your launch controller. You have two positions here. This is the position safe and this is the position arm. You pull that out, you pull it inside the arm, and then you can see it gives you a signal and then you are ready to go. Well, now you may ask, how is the parachute on top of that rocket protected from the heat of the rocket motor? Well, there is actually something that is called protection wadding that looks like that, at least in my case. And it is also called recovery wadding, but I actually prefer to call it protection wadding. And what you do is you take a little bit of that protection wadding and you put it inside the rocket. You can see that on that picture here. See, this is the parachute, this is the rocket motor, it is down here, and then you put some of that recovery or protection wadding inside that model rocket, and this wadding prevents the parachute from melting from the heat of the rocket motor.
So you just put the recovery wadding inside the rocket and you just take, for example, a pencil and you push it inside the tube or rocket body.
Okay guys, that was my analysis of my first and second flight of my Long March model rocket. I hope you liked it. In that case, give it a thumbs up, subscribe to the channel if you want more of that content, and click the bell icon to get notified immediately in case of a new video. Until then, take care and don't forget to rock it.